This is Dr. Sirisha, working as Associate Professor in Institute of Aeronautical Engineering. Today we are going to discuss about the concept of linked list, right? Precisely within that, double linked list. I hope you know what a linked list is. Linked list is nothing but a linear data structure where data is stored in non-continuous memory locations, right? It is similar to array in one sense. Both are linear in structure, but they face the opposite sides of a coin when storage comes into the picture. They are in array, data is stored in contiguous memory locations, whereas in linked list, data is scattered all over the memory, but they hook to each other by storing the address of the next data by each and every data point. Means basically in a linked list, every piece of data is known as a node. Basically, it will be known as a node, which is divided into two parts. The first part holds the data, and the next part holds the address of the next data part or the next node. Right? This is the story of a single linked list. Then, what are the drawbacks of it? Single linked list travels only in forward direction. Only in forward direction. Why? Because every node holds the address of the next node, but not the node which is behind it or prior to that, right? So to overcome that, double linked list have come into the picture. Double linked list is will look something like this. Have a look at this node structure of double linked list, in which it will have three parts. The first part, or the most important part, is the data part of it, where data is stored, and its left and right parts. That is, the left part is the previous one, which holds the address of the previous node. Next part is the one which holds the address of the next. This is how a double linked list can travel in forward as well as backward direction. Okay, so this is a simple node representation of a double linked list. What are the pros and cons of the same? The advantage, just know what I have said. We can run in both the directions, right? Forward, from pick any node, you can travel towards its head or towards its tail. That itself is the drawback or con of a DL. How? Every node must bear the burden of storing the address of its previous node as well as the next node. That is, space complexity raises. As every node must store it, its space complexity raises. So, that itself tells us that the amount of memory required to store the double linked list is very, very, very high when compared to your single, and it is the worst when you compare with your arrays, right? So these are the pros and cons of our double linked list. Then where this concept is used? Everywhere when you want to traverse forward and backward, like rewinding, playing videos or audio files, when you want to go move forward or backward, when you want to do that, you need a double linked list, right? So even in movies, image processing or audio processing, everything will be in terms of digital data, ones and zeros, right? To travel forward and backward, you need to have some data structure to hold this data, right? So if you want to traverse in both the direction, definitely you need a double linked list. No other data structure can help you out except ETL. Okay, so wherever you do these two operations, rewind or forward, that will be an application of your data. Okay, so the basic comparison between SLL and DL, single linked list and double linked list. Single linked list is very easy to implement because I'll be holding, that is, each and every node will be holding only the address of the next node, but not the previous node. That is not implementing double linked list is not so easy, because yes, every node have two-way relationship with the others. So to remove an element, that is to delete an element or to insert an element, you need to build four relations or to break four relations. Loads of hectic work it needs. Single linked list, less memory, and double linked list, more memory is required. And drawback of single linked list will be you can traverse only in forward, whereas in double linked list you can traverse in both directions. Right? So, what are the operations that we can perform? Insertion, deletion, and display. Display or traverse, you can say. Right? Basic operations. And the insertion and deletion are further divided into three different categories. One is insertion or deletion at the beginning, insertion or deletion at the last, or insertion and deletion at a specific location, right? Specific position, we can say, right? So these will be the three subcases of insertion and deletion. And insertion, deletion, and display are the basic operations. Let's see each and every operation one by one. With the help of Python code, I'm going to explain all these operations. Have a look at this, guys. Basically, to construct using Python, how to construct a node. So I have taken a class node, right, and a constructor, right, in it, which is going to take data as an input. It is going to take data as an input. You can see that I've made the next and previous as none, which means that when you create a node initially, it is not hooked to any other node. It is not having any relationship with any other node. So its previous and next part will be storing none, saying that it is a standalone node, right now not hooked to any. Then starts our class of DLL, double linked list, whose constructor have a pointer variable start, which is initially none. And I hope you know what a pointer variable is. A variable which holds only addresses, which cannot hold variable values. It holds only addresses. Okay. So initially start will be holding none to say that no list is being created yet. And that's why I do not hold any address. Okay. And CTR is the variable which I have used to get a count, to hold the number of nodes currently in my double linked list. That means at any operation at any point of time, you just use CTR variable, you will get the number of currently existing nodes in your double linked list. These are the two constructors in your two classes respectively. Let's go to the operations. Inserting at the beginning of a list, say double linked list. So the first and foremost statement goes with creating a node. If this node, NODE, small, is nothing but an object of class node which takes data as a variable. So with that, a node will be created, something like this. So whatever data you are going to pass to it, it will be placed over here, data, and its left end, right parts will be none. That is your previous, and the next part will be none, saying that it is not related to any variable. We have to build a relation. To build a relation, you need to take care of one thing. First of all, check whether the double linked list is existing or not. Right? That is a primary point. To check that, this is the condition which I need. Whether the start is having none or not. If it is having none, that itself tells us that double linked list is empty in nature. Nothing is created yet. If nothing is created yet, the node which you have created just now will be the first node. So place the address of that in the start, which will tell you that the first node is at some address. That is the address of the node which you have created. Or else, the case where a list is already existing means you have a handful of nodes in your double linked list. Now your task is to insert this node, the node, as the first node, right? So that is the piece of code that lines of code, which I'm going to explain you using animations in a while, right? So after inserting, I'm going to increment my counter. Why? Because as I said, CTR is the variable which holds the number of nodes in my double linked list, which I can use at any point of time, right? So if I'm using or I'm performing any one of the insertion operations, I'll increment the counter. If I'm performing any deletion operations, I'll decrement the counter. Okay, please keep that in mind. Now let's have a look at the animations. The first case, a case where your uh, 20 is the node which I have created just now. Okay, this is the node whose data part is 20, whose left and right are none, and which is located at location 8000. And this is the first case where my start is showing as none. Mane, there is no relation between any nodes, or it is saying that I don't have any nodes. Now I have to do the same. I built the same. Place the address of the node in start. Thereby, you can see the link arrow mark, right? So now start is pointing that my first node is at 8000. Okay. What is the second case? Look at this one. 20 is the new node. I have to place it as the first node. But already three nodes are existing. Money, 21, 22, and 23 are already present in this. You have to bring 20 as the first node. This is your task, right? Let's accomplish the same. I'll explain you one by one. Keenly watch, guys. Okay, the first step, node next what will be holding the address of the start. What is the address of what is the start? Start is holding 8000, right? So sorry, 5000. Place that 5000. Start is holding 5000. Place it in your next part of the node. So have a look at the changes which I have done in red color. So previously it was none. It has been overwritten by 5000. Thereby, look at this node and tell me what information you get. Name of it is node. It is located at location 8000. Its data part is 20. It doesn't have any previous node, but its next node is at location 5000. Am I right? So one relation is being established, but still there are few points. Even the node 5000 must also say that, and the node behind me is at location 8000. Am I right? Listen to me very carefully. The node at location 5000 must also say that the node behind me is at 8000. We need to establish that. Have a look at this one. So, what is node? Its address is 8000. Am I right? Where you are going to place previous part? Kiski previous part? 5000. What do you mean by self start? Just now I have said 5000. 5000 का previous हो गया this place. At this place, what you are going to place? Your 8000. Right? Now, let's do the exercise once again. Look at this node and tell me something what it is saying. The node is saying that I am at location 5000. My data part is 21. My previous node is at location 8000 and my next node is at location 6000. Guys, did I build a relation between a node at 8000 and 5000? Not. Still there is a problem. What my start is saying? Start is holding the address 5000, which says that the first node is at location 5000. But my task is to make the new node as the first node, right? So what I have to do? Very simple. Override the content in start with the address of the node, which is 8000, right? Now look at the start. What is it saying? It is saying that the first node is at location 8000. Thereby, have a look at the double linked list. Can you see a double linked list in which every node is holding the address of previous as well as the next, right? So this is how we insert a node at the beginning of a double linked list. Let's see the case where we perform the same at the end, insertion at the end. As usual, I'm going to create a node called the constructor. Then two cases. Case 1, if the start is none or a handful of elements are there. Okay, so the first case will be the same. Have a look at the animation. So a case where the start is none. By just storing the address of the new node in the start, I build a relation, right? What if I have a handful of elements? That means 21, 22 and 23 are already present in the list. I have to place 20 after 23, that is at the end. This is my task. Let's do the same. First of all, at every point of time, at the initial stage, we just have the address of first node in our hands, which our start variable is going to hold. Start holds the address of the first node. We do not have anything in our hands, right? So, have to reach the last node. We have to place a new node after it, right? So, very simple is give a dummy name temp to the start. So, the first node will get a dummy name temporary, right? So, have to reach the last node. What is the speciality of the last node? Have a look at this picture, how it is different from the remaining. You can clearly see that its next part is none. Am I right? So, what do you mean by next part is none? When you call that next part is none, only when you don't have any next node, right? Only in that case, the next part will be filled by none. Okay, so that is the checkmate point for me. So I'm going to hop from the first node to the next node until unless I reach a node whose next part is none. Right? So here is the logic. I don't know the number of nodes in my hand, so I have used while loop. While temp next is not none, I'm going to take the hops. Temp is temp next. Once I reach the last node, I have to build the relations. Very simple. Have a look how to insert at the last. This is the new node which is holding n and n at the left and right. If you build a two-way relation, job done. So let's see a piece of Python code for the same. Right? First of all, the address of the node, which is 8000, is placed in the next part of your template. Thereby, you can see that there is a relation and a new relation is being established between temporary and the node, right? Have a look. Now, it must be mutual. The relation must be mutual. So, even the node must say that my previous node is temp. Have a look at this picture. Now, the node's previous part is holding the address of temporary, which is 7000. Thereby, a dual way relation has been established. Now, have a look at this DLL. Can you see a DLL where a new node is being inserted at the end? Right? So, this is how we are going to insert a new node at the end in a double linked list. Now comes inserting a node at a given position. The first 2 points are the same. Reading a node and whether it is the first node or not, if chalega. Next comes the primary point. Primary point is to check whether it is the position where you want to insert the node must be greater than 1 and less than CTR. That is the total number of nodes. Why I have taken this condition is the primary question. Why I have taken? Because I don't want to mix the conditions of insertion at the beginning or insertion at the end. Because explicitly I have given two functions for these two tasks respectively. right? So I don't want to mix these two cases in my current job. So the positions should not be the first or the last. It must be some 2 to n minus 1 positions only. I'll handle this task. Okay. So now my task is, as I said, I hold only the address of the first one. Nothing is there in my hands. So till the position where I have to insert, I have to take hops. Have a look at the animation. You'll understand it more precisely. Okay. Have a look at the animation. The first case where the start is holding none. I'll place the address of the new node, thereby I establish the relation. What if I have a handful of elements? Have a look. So this is the list. 21, 22, and 23 is the current list, but I want to insert 20 at the third position. Money 21, 22, 20, and 23. Third position I want to insert. Am I right? So this I need to achieve. So how to do that is the task. One, how many relations? For example, guys, think this is the new one. Okay, whose previous and next part are none, saying that we don't have any relation with anyone. To build a relation, how many relationships you have? Arrows. Node at 6000 must say that my next node is 7. And even this guy must say that my previous node is at 6000. Two relations are with two lines. And the node at 7000 must say that my previous node is at location this, and even this must say that my next is at location 7000. And 4 relationship diagrams, your relationships you have to establish, right? When you establish that, automatically these two relations will be broken down. Let's see how I'm going to do that. Okay, as I said, I need to take the hops. I need to reach the position where I have to insert. So I have reached my place. Okay, using the while. Now, the first step, temp next. What is there in temp next? 7000, right? Where I have to place node ka next. If I place that in nodes next, what node is saying? Have a look at this picture node, this single node. It is saying that its next node is at location 7000. I established one relation. Next one. Relations are mutual, right? If node 8000 is saying that my next node is at 7000, even 7000 must say that my previous node is at 8000. The same I have done. What is node? It is 8000. Where I have placed it? Temporary, next, previous. What is temporary's next? 7000, right? 7000 का previous part हो गया ये. In this position, place 8000, right? With that, I build bridge between the node and a node at 7000, right? So previously there was a relation something like this. 7000 was saying that my previous node is 6000, which is broken. Now 7000 is saying that my previous node is at location 8000, right? Okay, one step we have achieved. Let's go for the next one. Here it is. Place the address of node at temporary next. What is temporary का next? ये हो गया 8000. यहाँ पे place your address of the node at temporary next. Thereby, you have broken this relationship also, where temporary was saying that my next node is at 7000. You have broken that also. As these relationships are mutual in nature, even node must say that my previous node is at 6000. The code for the same. Have a look at this one. Temporary is placed on node's previous. Okay, so now you have a look at this one. Now you look keenly at this node which I have inserted at position 3. What it is saying? It is saying that its name is node located at location 8000. Its data is 20. Its previous node is at 6000, whereas its next node is at 7000. Can you see a double linked list where recently I have inserted a node at a given position, right? So this is how you are going to insert a node at a given position. These are the three cases of double linked list to insert an element at beginning and at a given position. Similarly, we can do the same in case of deletion also. Deleting the element at the beginning. While deleting an element at the beginning, we need to be extra cautious, a bit extra cautious. First of all, check whether the list is existing or not. To check that, very simple test, litmus test, check whether start is holding none or any address. If it is holding none, that means the list is empty. You can simply say that no node exists. If nothing exists, there is no point of deletion itself, right? So that is one case. Second case is a case where your number of nodes is only one. That is, only one node is in the list. In that case, deletion is one task and placing none in your start, stating that the double linked list is empty now is the other task which you have to do. And the third part is a normal case where you delete. These are the steps where you are going to delete the nodes, the first beginning. Okay, let's look at the animation of the same. For example, a single node exists in your list. Simply break it. Make the counter as 0 and put none in your start. That single step will do the same, right? Put none in your start. With that, itself will say that the list is empty, right? There is no relation. This relation, whatever the relation was here, has been broken down. Now have a look at this one. The list is 21 followed by 22 followed by 23. Now your task is to remove 21. This must be your new list. Let's see how we can do this one. Remember always start holds the address of the first node. Simply change the content in the start. Change the content in the start. Give the address of the second node, which is 6000 in your start. The start is saying that my first node is at 6000. That itself makes the previous first node null and void. Its location is 5000. Have a look. Is anyone using? Your current first node is holding it in the previous part. Make it as none. That is the next step. Right? So place none in the start's previous part. What is the start? 6000. Iska previous part, this one. Place none over here. Thereby you can see that the node with data part 21 is not having any relationship with any node in the current double linked list. This is your final double linked list after deleting a node at the beginning. Right? I hope you are following me very well. Next, deleting a node at the end. The first two cases are the same, where I'm going to check my double linked list is nil or it is having only a single node. Right? The else part talks about the cases where it is having handful of elements where I have to remove the last element. Let's have a look at this. If a single node is there, place none in the start, thereby you are breaking the relation. That is fine, which you have seen earlier. Now, this is the task. 21, 22 and 23 is your current list. Now the task is to remove the last node. This must be the result. Okay. So as I said, I have only the address of the first node in my hands. Nothing is there in my hands. So I have to take a temporary name to the first node, a dummy name, and I need to travel to the last. What is the significance of the last node? The last node holds or have none in its next path. That is the next address point, right? So that is the benchmark for me, and I'm going to travel to the last. Once I travel to the last, as I have to remove that node, I cannot stand on that node. So I have to take a hop back. So I'm going to take a hop back. That is temporary previous is step none. Right? Have to make this as the last node now. Temporary next part. Make it as none. It's very simple. Temporary next part, make it as none. Thereby, the last but one node have broken its all ties with the last node. Right? Have a look at this one. So this will be your final double linked list after deleting the last. The third case of deletion, deleting a node at a given position. Right? Same old case. I'm going to check whether the linked list is existing or not to delete any node. The other part is that position should not be the first nor the last. Okay, as I have exclusively written deletions for the first and the last cases, right? So the remaining I need to think of, right? So the first case where the list is having only one element, I am going to break it by putting none in the start. Next, here is my task. Very simple. Have a look. Simply, I can draw 21, 22, 23, and 24. This is my list. My task is to remove the element at third position. That is 23. That means 22 must point that its next element is 24. Got it? This is what I have to do. Let's check how I'm going to do this. As I said, I need to reach that position. I'm going to take 10. Okay, a dummy name to the first node. And I'm going to take the hops and I reach the node which I have to remove. Right? Now my task begins. Let's look at the picture and think. Just roughly, forget about the code, Python code, forget it. How you are going to remove it? By simply you can say that node at 6000 say that its next node is at location 8000, and node at 8000 if it says that its next node is at 6000. Don't you think the task is done? That's what I'm going to do. Have a look at my pieces of code. First of all, temporary next. What's there in temporary next? 8000. 8000. Where you are going to place it? Temporary previous. What is temporary previous? 6000. 6000 ka next this place. At this place, I have placed 8000. As soon as I place that, what you can see, the node at 6000 is saying that my next node is at 8000. Right? Have we broken a relation or not? We have done it. Next, temporary previous. Temporary का previous हो गया 6000. Where you are going to place it? Temporary next. What is temporary next? 8000. 8000 का previous this part. In this part, you are going to place temporary previous which is 6000. Thereby, a node at 6000 is saying that its next node is at 8000, whereas a node at 8000 is saying that its previous node is at 6000. Have you seen that? We have proven two relations. There was a relation, something like this and like this, which we have broken just now with the two statements. Still two relations are there. Can you see that? Temporary is still saying that my previous node is 6,000, my next node is 8,000. Have to break it. Simply make them as none. Does it become alone or not? Are you not going to delete it? The same thing I am going to do now. First temporary next को none बना दो, then previous को none बना दो. Can you see that? You have deleted a node at a given position, right? Now the node at location 7,000 is not pointing to any node, is not pointing to any node. Therefore, you have deleted a node at a given position, right? This is how you are going to do that. As double linked lists have a beauty of traversing forward as well as backward, we have two traverse functions, traverse forward and reverse. Well, look at the first function, traverse forward. Always I take all these precautionary steps. I always check whether the list is existing or not. Only if it exists, I go for traversal, or else I'll not. I'll just say that no nodes exist and I quit. Okay, so that is a precautionary step which I have taken. Self start is none. I'm going to print no nodes exist. Else, give a dummy name to the start or the first node, and with every hop, print the content in the node unless you reach the last node. To reach the last node, either you can use the condition saying that temp next not equal to none, or use the CTR, that is the count variable, which holds the total number of nodes in your list. Either of the conditions will serve the purpose. Okay. The second function, traverse backward. Okay, traverse backward. So to traverse backward, first of all, you have to reach the last node. What is the condition to reach the last node? What did I tell you? The significance of the last node is that its next part will be none. So this is the while loop which I have used over here. I'm going to take the hops from the first node till I reach the last node. Once I reach the last node, I'm going to travel to the first node till the first node, and I'm going to bring the content in each and every node unless I reach the first node. Even here you can have the condition saying that temporary previous is none. That is the significance of the first node. First node cannot say that some other node is there in front of me, because that itself is the first node, right? So you can have a condition saying that while temp previous is none, or you can use the control variable also, the count variable, count variable which holds the number of nodes in your double linked list triangle. Okay, these are the functions or the operations that you can perform on a double linked list. The three categories or three cases of your insertion, 3 cases of deletion, and 2 cases of traversal. Okay, I hope you understood what a double linked list is with my bits and pieces of animation and Python. Thanks a lot.
Like, share and subscribe. Hit the bell icon for more updates.